So far, this chapter we have talked about three ways of solving quadratic equations. The first one is that we like to factor our polynomial if it factors. We know that if it's set up in a certain way, we can use square roots to help us solve. And if not, we can complete the square. So we could on this, since it doesn't factor, we could move the 2 over, put in a new constant there, and then we could use our square roots once we got it factored and broken down. Okay, the fourth way we're going to talk about, and this is the way that works no matter what. No matter what the problem looks like from the beginning, whether I could factor it or not, whether or not I want to try to complete the square, and that's the quadratic formula. Now the quadratic formula comes from completing the square, actually. And if we start with our equation set equal to 0, which is how we would like to have it if we're going to factor it, then if we complete the square using the a and the b and the c and leaving them as they are, this is what we end up with. So a is the number in front of our x squared term, which down here would be 1. The b is the number in front of the x, which is -6. And the c is the constant term. Here it would be -2. If it helps you, if this is new to you, it's a great idea to make yourself a list off to the side. That a is 1 because we have 1x squared, b is 6 because we have plus 6x, and c is -2. From here, we plug in, and while this is a tedious formula, again, it's going to work every time if we're careful with our arithmetic and if we clean things up all the way. So we said b is equal to +6, and we want to start with the opposite of b. So the opposite of +6 is -6. Okay, the plus or minus, that's where our two solutions come from. One from the positive case and one from the negative. Underneath here, we're going to have b squared minus 4 times a, which we said was 1, times c, which we said is -2. We keep the signs, which means we have to be careful with our arithmetic when we come back and clean it up. On the bottom, that whole thing is divided by 2 times a. So from here, once we've plugged in b, a, and c, then we go through the correct order of operations and we simplify things completely. Okay. So under the radical, those are kind of like grouping symbols. We're going to work on this expression right here. I'm going to draw a little arrow up here to do the arithmetic. If we take 6 squared, that's 36. If we have a negative times a positive times a negative, that ends up being a positive number, and 4 times 1 times 2 is 8. So under the radical, we have a 44. Next thing I want to do is simplify that radical if possible. And if I give you enough time, hopefully you would figure out, let me start over on that, that a 2 gets to come out from under and an 11 is stuck underneath. Now from here we always want to leave our fraction in lowest terms if it's not already. I have a 2 on the bottom and I have a 6 and a 2 up here, which means I have a common factor of 2 that I can take out of all the pieces. Okay. Or if you'd rather look at it as 2 separate fractions, we can take each piece divided by 2 and then reduce. Okay. The 2's go away and we're left with -3 plus or minus the square root of 11. All right, let's try a couple more. So up here, if we need to take a minute to make ourselves a list, the number in front of the x squared is a positive 3. The number in front of the x is positive 1. And our constant term is positive 2. Now again, if the instructions on our paper just say solve for x and they don't specify a method, I'm always going to try to factor it first. But if I check, there are no two factors of positive 6 that add to be negative 1, so I know factoring is not going to get me there. This expression is not set up so that I can use square roots, and I could complete the square, but there's a 3 in front of the x squared, and my teacher didn't show me how to do that yet. So that means I'm going to jump to the quadratic formula. Okay. So if b is positive 1, I'm going to start with the opposite of b. Underneath the radical, we're going to have b squared minus 4 times a times c. That entire thing is over 2 times a. After I've plugged in, and I'm going to recommend that you be very literal and write all these steps down instead of trying to absorb this and do parts of it in your head for right now. If we take 1 squared, and I'm going to scribble off to the side, 1 squared is equal to 1. 4 times 3 is 12 times 2 is 24. I have 1 minus 24 there. 2 times 3 on the bottom is 6. Now when I'm simplifying the radical expression, the best I can do, since 23 is prime, is I can bring out the I. So we have I times the square root of 23. Okay, we also know that the rule when we have complex numbers is we can't leave a big ugly fraction like this. So while if it's a real number, lowest terms is always required, but we could either split it or leave it as one big mess. However, if there's an I involved, we have to split it so we can see the real part and the imaginary part. Okay, so here are our two solutions to that equation. I almost made it. On this one over here, a is positive 2, b is positive 5, and c is positive 1. Let's actually change the problem here and make that be a negative 5, just so you've seen one before we go to the next page, where I set you free. So go ahead and pause the video, plug in the A and B and C, turn it back on when you want to see if you're right. Alright, so b squared minus 4ac gives you 17. Square root of 17 doesn't simplify. We don't have to split this one into two pieces because this is a real number, so we can stop right here. Now, as I always tell you, the only way to make the problems any harder is to create problems with more steps. So if we look at both of these examples, the first thing we see is they are not equal to 0. Let me get my formula down here too. Okay. So the first step is to get everything on one side of the equation. It doesn't matter if I move everything to the left side, it doesn't matter if I move everything to the right side, but I'm going to get everything onto one side. Once I have a 0 on one side, again, if I'm given complete freedom to do what I want to, then I would try to factor this. Because the 3 is a positive, then this doesn't factor. I don't want to complete the square and I can't use square roots, so I'm going to go to the quadratic formula. Go ahead and finish this one, pause the video, finish this one, come back on and check your work, and then give that one a shot beginning to end all on your own. A is 1, B is 2, C is 3. So the opposite of 2 is negative 2. When we go through the arithmetic, we get 4 minus 12, which is negative 8. under the radical. Simplifying that, a 2 gets to come out with the I, and a 2 is stuck underneath. If we take 2 over 2, we get 1. Here, if we take 2 over 2, we get 1, I square root of 2. If you haven't worked through this one yet, go ahead and pause it and work through it. When you turn it back on, the solution will be here. Okay. If you're ready to go, I'm going to get rid of that box. First, we need to get a 0 on one side. Okay. A is 1, B is negative 2, and C is negative 7. So the opposite of B is positive 2. We go through and we get 4 plus 28 because of these two negatives right here. 32 under the radical, a 4 comes out, a 2 is stuck. 2 over 2 is 1, 4 over 2 is 2, with the square root of 2. Okay, practice some of these odd ones in the book. Get a hold of me if you have questions.